Hi, my name is John Zay. I am the Department Chair of the Mechanical Electrical Technology Department here at Sacramento City College. The MET program, Mechanical Electrical Technology, it's a 2-year commercial HVAC/R, which stands for Heating, Ventilation, and Air Conditioning and Refrigeration. The demands being placed on HVAC mechanics, technicians these days are really, really high, a lot more than they were 20, 30, 40 years ago. So for the students to be able to meet those demands, they need to know a lot of basics. So we start out teaching the students basic mechanics, basic fundamentals, and how commercial systems are put together. What are the different components? How they all intertwine? And so when they get to the 3rd and 4th semester, where they start dealing with controls, they have a really good understanding of how everything is interlocked. We have 3 main labs. That would be LUC 10, which is where the students actually start out in their 1st semester and they learn about basic mechanical systems and refrigeration. Then we have LAC 9, where that would be our upper division classes, where they deal with controls and instrumentation. And then the 3rd class is LUC, or the 3rd lab is LUC 116, which kind of deals with the intermediate students, and that will focusing on electrical and gas-fired heat equipment. This is where everything starts. This is the largest of our labs. This is where the 1st semester students come in, and they learn about basic mechanical systems and mechanical concepts about refrigeration and about the different thermodynamic properties of the materials that we deal with. So they'll spend 2 semesters in here working on refrigeration systems, and this is what they work on. Students have to, they have to pipe and do some minor electrical on what we call a TR box, or a training refrigeration box. Oddly enough, interesting enough, is that these boxes, some of these date back to the early 50s, the others date back to the early 60s. There's 2 series. We are now in the process of putting new condensing units on, and you can see all the new units, and that's about half of what we need to change out. So we always got some project going on doing something. So in this lab, this room, LUC 116, this is where the students start learning about electricity, and then we also get into to gas-fired heat systems. So this would be your 2nd and 3rd semester students. Over here we have an air handler that the students learn some basic electrical troubleshooting, learn how to read electrical schematics, and then over here we have, this is just a condensate pump, but what the students do here is that they have to pull the motor off and make a gasket by hand, and then put it back on, and it can't leak. That's you know, that's one of those skills that are required from time to time in the field, because we always need gaskets. And then over here, this is part of a steam boiler that we teach. The different components when we talk about gas-fired equipment, and primarily boilers. And then back here, this is a condensing unit for a VR, variable refrigerant flow system that we're in the process working with manufacturers to get installed in this room, which is going to be really nice for the students and for whoever hires the students. Over here we have a bunch of electrical trainers where students wire up and actually and then they wire them and then make sure that they do functional tests on them. So over here we have a couple package units that the students actually do. They actually do compressor changeouts. This one, the compressor sweated in, so they learn how to recover the refrigerant, unsweat a compressor in a safe manner, sweat it back in, evacuate, and then recharge. All right. The one over against the wall is, this one has a rotor lock. So here's a rotor lock fitting right here. So all they have to do here is undo this nut, and then the sealing point, there's a nylon washer that goes right here. So they get experience on the two different ways compressors are connected into this system. Since on this unit, since the compressor's down deep, we built this A-frame affair right here using a come-along so that we can actually remove the compressor without the students injuring their back. One of the things we emphasize in this program is safety. My rule, even when I was out in the field, is you don't go home any worse than you came into work, all right? So, and we want our students, we don't want our students getting injured at school, nor do we want them getting injured on the job. This is electrical display that the students work on to get a better understanding of how power comes into a facility. This one is residential, just because it has less components and it's kind of easier to understand. And then we work in from single phase residential type power, then we'll go into three phase in the last semester, since our technicians are typically working on a lot of three phase. Over here, again, like I said, I like the students to work on real equipment. So this is just a standard exhaust fan. So, but what the students learn to do on here is they learn how to align the motor and the fan shaft, and how to adjust belt tension. And we do it both on single shiv and two shiv. So they get the two combinations. Having a two shiv is a little tricky on a one shiv system, but we managed to overcome that. Okay, this is LUC9. This is our controls instrumentation lab, where we conduct lecture. So it's a combination lecture lab room. And we also do some of our real advanced training here, where we do our building commissioning, energy auditing, and air and water balance classes. They're all done out of here. So the computers can do computer modeling on, we have 25 computers for the students to use. They also can access Metasys through these computers. And then we have different DDC trainers that we use in this room. And the air handler, okay. So this air handler up in the attic space, we also control that air handler. And that one, the heating and cooling comes from our boiler plant and from our chiller plant. The other thing we have up here are VAV boxes. Right. And the students can go on to the Metasys program. They can adjust the airflow, and then they can come back and actually take physical measurements of what the airflows are at the register and compare them to what the readout is on the BAS system. So in this room, the students learn the theory behind automated controls, and then they also learn how to adjust them and set them up to meet the demands of the building. So we also do PLCs out of this room. And so if we start looking at the trainers, right here, this is a pneumatic trainer that the students do lab work on, and it represents a commercial HVAC fan system with heating and cooling. This one here is for DDC, right here. We worked with RSD last year, and they helped us out a lot on developing 10 DDC trainers that are all the same, which is nice because it's nice to have all the same trainers, because then the students get to help each other. You pair up the students, and then you assign them each a trainer, and then you explain it, what you want done, how it works. The students try to make that happen, and some students catch on better than others, so the ones that have a better understanding help the ones that don't. And then the instructor can walk around and then help, also help the other students. So it works out really, really well. Okay, so what we're looking at, this is our Metasys, our BAS system, and this is Air Handler 10. And so we're going to use this, the students use this to monitor temperatures, and then they can actually control the different valve settings and on manual override, and see how it affects the temperatures of both the supply air, the room temperature, and the return air. So this Air Handler 10, oddly enough, feeds the large lab, which is LUC10. So this is our balance lab. And in this particular room, we're going to do both air and water balance. So if you look up here, this is a, would be typical of a residential system, because it's what would fit in this room. And so here the students, they learn about airflow, how to balance, and we put holes in some of the ductwork so they can, they'll learn how bad ductwork affects overall performance. And the part that I really like about this is that we have 2 spots where we can hook in return air ducting, so we can put in different size air ducting. It could be oversized, it could be sized correctly, it could be undersized, and the students get to see how that affects overall performance of the system. So as you know, we learn by doing. So we have them do. On the far wall here is our balancing system. We'll use that in our upper division classes. And on this system, it's just so the students learn how to balance coils. And we pipe the coils in correctly. One set's in correctly, the other set is installed in backwards. So that they have the opportunity to see what happens when you install them correctly, and what kind of problems you're going to have when you install them in backwards. And then we have 2 pumps. You can't see them. One is an inline across the line pump, and the other pump is a VFD driven pump. And then we have other air handlers in here that we converted over where the students learn how to measure airflows. One's across the line, the other one is VFD driven. This is where we heat and cool our building from. So the equipment really doesn't belong to the department, it belongs to the campus. But we have an arrangement with the campus facility folks that we operate it, we maintain it, we can do whatever we want. We repair it, they buy the parts, so it's a good marriage. And I think they're comfortable with it, because if we make a mistake and the system goes down, the only people who are affected is the people in this program. So we have to live with our consequences, just kind of like out in the field. All right, so this is our boiler room, and in this boiler room we have 3 boilers. They're all operational. We have a low pressure steam boiler, and then we have a water boiler with an atmospheric burner. This would be our lead boiler, and then we have a low NOx boiler. All right, so this room here provides all the heat for half of our classrooms. It comes, actually that really comes off of this boiler, but we can use any other boiler we want to. So on the steam boiler, the students learn how to operate it, and they also learn how to do water chemistry right here. So here we do a little chemistry, they test the water, and then we treat it. The operation of the boilers, the circulating pumps up here, they're all controlled by our BAS system, which we use Metasys. So not only do the students learn how to come into the room and physically start and stop and run a boiler, but they also learn how to use a BAS system and everything has to be started and stopped through the computer. So this is our air handler electrical room, and this is the air handler for our largest lab, which is LUC10. So, and not only does it move air, but we also condition the air, so we have the ability to cool it with chill water, which is just cold water running through pipes. We have the ability to heat it using hot water, or we can heat the air using steam from our low pressure steam boiler. So again, this equipment, the students do all the maintenance on it. They regularly change filters. They run a series of tests to make sure that the control valves are operating properly, that we get the right delta T's across the coil. And we can look that up on the BAS system, but we also verify by coming out and taking actual measurements. Over here, this is our MCC panel, which stands for Motor Control Center. And here, the students actually, we open up one of the buckets here, and the students actually have to take amp draws with a clamp-on amp meter, and then they also have to physically go in, and take amp voltage readings across all three legs to make sure that we don't have an unbalanced voltage condition, all right? And then over here, we can monitor the different circuits on this MCC, and we can see whether what the voltages are on each phase, what the amp draw is on each phase. We can see what the kWh is. And apparent power, reactive power, which is really good because students don't understand reactive power and apparent power and real power and how it affects the overall electrical system in large complexes. So we spend a certain amount of time trying to explain to them how important it is for them to understand that whole concept. This is our cooling plant, and the heart of the plant is this 40-ton chiller, and we cool water that's in the pipes covered by the white plastic. That cool water goes out to the air handlers and absorbs the heat. And then we use condensing water to remove the heat out of the refrigerant, and this ultimately goes to the cooling tower. The piping system is a primary, secondary system. So the primary pumps are constant speed, and the secondary loop pumps are off a VFD drive, which are against a far wall. This chiller, it can pull down to 19 degrees because it has a glycol solution in it, right here, that we keep in the system that keeps the water from freezing. So this chiller is capable of manufacturing ice in our ice tank. And we use those sets of pumps to do that with. We have a plate and frame heat exchanger. So we have three methods of cooling our buildings other than outside air. We can use the chiller to cool the air, to cool the chill water. We can use the plate and frame and the cooling tower on the cooler days, or we could use our ice bank to cool the water. So the students, through the Medisys program, that's one of the things they do is learn how to shift from one system to the other, and then they have to learn what valves open and what valves close. And one of the projects they have to do in the beginning of the class, the semester, is that they have to draw out this whole piping system. And you would think it's pretty simple, but it's actually pretty hard. They really start getting confused on the way the pipes go. But it's a really good introduction on students learning the overall system approach. How does this all work? And then, which is so important, because when you get into the control systems, you can't control something you don't know how to work. So all this stuff that all these different levels of training that the students do on the low end all come together when they and really support what they're learning when they start learning about control. Okay, so one of the maintenance things you do on water-cooled chillers is you have to what we call punch tubes, because inside this condenser, inside this barrel, we have water that runs through tubes and refrigerant on the outside of the tube, and so we have to clean the tubes so we get good heat transfer. So we clean our tubes twice a year. Why? Because I have a class twice a year, and that's what we do. So we use a good way tool. We use the nylon brushes, and we change the gaskets, and then we talk about these other devices that can be used, but we don't recommend. But so now the students get the experience in how to punch tubes. It's a simple job unless you've never done it. And then they realize, wow, this is a simple job. So this is a coupon rack supplied by Garrett Callahan. They also support the program, especially in water treatment chemicals, for our chill water loop and hot water loop and our steam boiler. But here the students can see how we put in coupons and then pull them out, and then we can measure the corrosion rate that's occurring within our piping systems. So right now we're in the mechanical courtyard, and this is where all our outdoor equipment is housed. We have our cooling tower, we have an ice bank, we have one of our newer additions that we're working on right now, which is a multi-zone unit that the students work on. This actually came from one of the buildings here at Sacramento City College that was tore down, so I was able to rescue it and have it brought over here for the students to work on. So this corrugated tank right here is, this is for our ice bank, so we can produce ice at night and use it during the afternoon to shave the peak electrical load. Our system goes down to 19 degrees. That's the shutoff point for our chillers. This is inside this container. It's filled with water, which has a glycol solution in it that runs through tubes, and the tubes are surrounded actually with non-treated water, and when I say non-treated, it doesn't have a glycol solution, so it will freeze at 32 degrees. And then we freeze the water at night when the electrical rates are low, and then in the afternoon we can harvest the ice by running what we call chill water through it, and that ice will cool the water so that we can cool the building with it. All right, this is the Energy Labs air handler. It's a multi-zone system. We acquired this when the college tore down one of the buildings a couple years ago, and the college was kind enough to let us have it. So right now we're in the middle of construction, where we're going to incorporate it into one of our training pieces. Last year we hooked up the electrical, and then we'll run cables around to the ground over to here to fire it up and provide power. And then what we're going to do this year is, this is, I don't know, that's probably bad, huh? This is the inside of the air handler. This is the blower motor and the blower, and we're gonna put a VFD drive on that motor. But the thing I like about this air handler, it adds a lot of realism to the trainers, and the students actually have to crawl in there and work on it, and that's what they have to do in the field. So they get a really good feel for exactly what the expectations are gonna be. Over here we have a couple rooftop units, 5-ton. One is a heat pump, the other unit is a gas pack, so it'd be gas-fired, electric cool. Students work on those, and you can see the tape up there on the ductwork where they determine the duct airflow. And in farther back by the fence, we have residential type split systems where students learn how to put on gauges, read them, and also learn how to ensure that the charge is correct. And if need be, charge the unit using charging charts. What we're looking at right now is the cooling tower, and that is the last process, the last step in removing heat from both LUC 10 and LUC 9 on the other side of this wall. This is part of the living lab. The students, they do the water treatment on it, they do the maintenance, they do, and they do the any repairs that are required. So a lot of good experience that they learn, and this is a fundamental piece of equipment that you'll see in commercial HVAC. So I just walked past the cooling tower. It's mid-morning, it's starting to warm up outside. And I noticed that I can hear water, and I think hopefully you can hear it through the mic. And so that's telling me that the chiller is about ready to start because we need to cool. And that's one of the things that we teach the students is that use your natural given talents such as hearing, sight, and feel, because those are the primary indicators that tell you what's going to happen if things are going correctly or things are not operating correctly. So one of the things that I try to impress upon the students is when they walk past this cooling tower is listen to the sound, learn the sounds of how a properly operating cooling tower should work. If I didn't hear this noise at this level, that would tell me there's a problem probably with one of our pumps. Maybe the pump lost its prime, there's some air in it, there's a valve closed, but something's wrong. So, and then we're going to have other issues caused by the lack of proper water flow. So again, this is an example of a living lab where we're around the equipment and we get to learn how it sounds, and we're going to use our ears as a primary method of detecting whether equipment is operating correctly or there's a malfunction. I think the part about what I do that is most satisfying is that it's the interaction with the students and watching the light bulb come on when